All right, guys. So there was a couple questions on the homework tonight. So I'm going to go ahead and do number one, and I hope that helps. So this one is a mixture problem. So tea worth 75 cents per pound is mixed with tea worth 90 cents per pound to produce 10 pounds of mixture worth 85 cents per pound. How much of each type is used? So right away, I can tell that I have one type of tea that's worth 75 cents. The other type of tea is worth 90 cents. So I'm going to go ahead and just label it. You can label it T1, T2. I'm just going to go ahead and do A and B. I have two types of tea. And then I have total. I'm just going to go ahead and use a quantity value table to help me kind of organize my information. And then from there, I can set up a quick equation and then solve for one of the t's. Uh, Quantity, here I have, well, in this case, A. I have a total of 10 pounds. Instead of defining the second T as B or another variable, to figure out TB that's worth 90 cents, I'm going to go 10 minus A. Okay, so my value right now, the first T is worth 75 cents. My second T is worth 90 cents. And this is the tricky part. We haven't actually done this box yet, but this tea right here is a mixture worth 85 cents per pound. Well, if you think about it, if you have 10 pounds of mixture and it's 85 cents per pound, you can actually find that unit rate by multiplying 85 cents per 1 pound 10 times. Okay, so that means it can kind of let you know that we're finally using that box. We're using that box because we have this combination right here. We have 10 pounds of mixture worth something. Okay, and then to find this last column here, we just multiply straight across. So I have 0.75 times A is 75.75A. Multiplying straight across again, I have 9/10 times 10 minus A. And then lastly, I'm going to go ahead and do this one. I'm going to multiply 10 times 0.85 cents per pound, which will be 8.5. Okay, so each one is going to be worth 8.5 cents per pound. Okay, and then what I'm going to do now is just kind of look at my system, make sure that everything's canceled out, make sure that I didn't leave anything out. Sorry, that's not 8.5 cents. That's $8.50 because if I have if I have 85 cents for every 1 pound, you add that 10 times, right? You go all the way down to 10 pounds, you're going to get $8.50. So if Mr. Wayne went in there and actually bought the entire 10 pounds of mixture worth 85 cents per pound, I'm going to have to pay them $8.50. Okay, sorry about that. Anyways, so right here, this A minus A is gone. 10 is equal to 10. There's nothing that I can do with this column. There's nothing I can do with those two columns. So naturally, what I'm going to do is just work on this one. This is where my system becomes. I'm going to have 0.75A plus 9/10 times 10 minus A is equal to $8.50. And then from here, hopefully you guys can do this step. 9/10 times 10 is going to be 9 minus 9/10 A. Drop everything else down that did not get canceled out is equal to $8.50. And then from here, I would do my squiggly. I know that I have 0.75, positive 0.75. Take away 9/10. And all I have left is negative 1500 A plus 9 is equal to $8.50. From here, I would subtract 9. Bring down the negative 1500 A is equal to negative 50. Because here we have negative 9 plus 8.5, you get negative 50. I would divide both sides by negative 1500. And I get A is equal to A is equal to, sorry about that, I was just reading an email. I get A is equal to 3 1/3. Okay. And then naturally, for B, all I have to do is B is equal to 10 minus 3 1/3. So naturally, B will equal 6 2/3. Because those two put together should equal 10 pounds. Okay. So I need to mix. So I need to mix 3 1/3 pounds of the 75 cents with 6 2/3 pounds of the 90 cents. Okay, and there is my final answer. And I hope that helps. So some of these problems you will actually use that middle column because, again, this one you have a combination. You have 10 pounds of mixture worth 85 cents. Okay. All right, guys, I hope that helps. Email me with any other questions you have. Thanks, guys.